Hey folks, Doug Blake with Body Design University. And in today's video, I want to talk to you about the motor unit. Now, quite often, and I'm asked by students both from an academic perspective and from a real world perspective, especially those folks that are trying to become trainers, obviously, in order to pass exams and know some academic information, the motor unit is probably, top 5 pieces of information you need to know because it is so profoundly important in the neuromuscular system and relates to, right? So that's academic and relates to the real world of training. From an athletic training perspective, which for the most part, that's where I did most of my initial training was with athletes. So working with athletes, I had to be very, very aware of how the mechanisms work. Because for the most part, they're like machines. If I want to make somebody run faster, well, I got to figure out from a mechanistic standpoint, what do I have to do? Do I got to make certain muscles contract harder, contract stronger, faster, whatever the case is? Always thinking mechanistically, how do I make that machine? I know they're people, but they're like machines to me in one sense. And so I was always thinking, what is it? What is that one, maybe 2 or 3 things that's critical? And so that's what I want to talk to you about in this video, is a kind of a brief explanation of understanding the importance of the motor unit itself. So if you don't know what the actual definition of a motor unit is, pretty straightforward. It's simply a single nerve cell and all of the muscle fibers that single nerve cell innervates. And if I can draw you a picture, it makes even more sense. And so the idea is that you have nerve cells, right? So let me backtrack just a little bit, right? Your spinal column, right? Your spinal column back here has all of the apparatus, neurological apparatus, to make sure or to create electrical impulses that are going to leave the spinal column, the nerve cells in the spinal column, and go out right through all their different branches to all the different muscles in the body, right? And we're talking about specifically skeletal muscle tissue. Now, the thing to remember, though, is that the spinal column, all those nerves have to be sort of activated themselves, right, by other nerve cells. And those are generally, obviously, going to come from the cerebral cortex in general. Not that that's the only place where nerve stimulation comes from. But when you think about wanting to flex your bicep, that comes from here, right? Your cerebral cortex, right? So you're thinking about something. That nerve impulse from your brain goes down to the spinal cord, to those particular nerves that are going to then reach out and touch those particular muscles that you're trying to contract. So we'll keep it simple and say your bicep. So I'm grab a 10-pound dumbbell and I want to do a dumbbell curl. Well, the first thing I got to do, I've got to think about it. And then I got to say to myself, okay, I'm going to curl this dumbbell up. Well, what happened? The nerve impulses from the thinking part of my brain go down into the spinal column to those nerves that are in the spinal cord. So it's kind of like if you ever see a relay race, right? You got one runner and they're running and then they hand off the baton to the next runner. Well, it's kind of this, it's pretty much the same thing. Now, there are these things called interneurons and yada, yada. Let's not get into that. It's a little bit too deep into the weeds. It's not necessary. Ultimately, I think about a movement. It tells the baton is handed off ultimately to these nerve cells themselves, that the body of the nerve cell is located in the spinal column, and then it sends an impulse out to the muscles. But it does so in discrete, unique bundles known as motor units. So if you have, and again, I can simply show you, if I draw like a nerve cell, it's a nerve cell, right? And so nerve cells have these things that come off it, right? You've seen this. You've seen drawings like this. You probably did this when you were in high school chemistry. It's got a nucleus, and then it's got a long, what's known as an axon, right? An axon that connects to or is going to what we call innervate muscle cells. And you just imagine that these guys are all muscle cells. And what happens is the axon of the nerve cell actually branches off into all these different branches. So you can see that it's basically the nerve cell is attaching to right? You can see the nerve cell attaches to these muscle fibers. And the concept of a motor unit is it's a single nerve cell, and whatever that number is, it could be 5 muscle cells, it could be 5,000 muscle cells. Yeah, a single nerve cell, right? We find these nerve cells in the spinal column connecting to 5,000, upwards of 10,000 muscle cells in some cases, like the quadriceps muscle. The point is that these unique, discrete electrical sending units are known as motor units. Why is that important? Okay, but by the way, motor units can come in many different sizes. I'll give you a great example. The muscle motor units in your muscles that make your eye turn left to right, those ocular muscles, in some cases, they're only 5 to 10 muscle fibers big, meaning a single nerve cell only attaches to 5 of them. So every time that nerve cell sends a electrical charge, okay, what we call an action potential, once it sends that action potential, it only touches or hands the baton off to like 5 muscle cells. You ain't generating a whole lot of power with 5 muscle cells. But what if I had a nerve cell, for instance, located down midpoint in the thoracic spine, and that branches off to larger muscles of the trunk, and most of the muscles, superficial muscles in the trunk, the gluteal group, gluteus maximus, and the legs, for instance, the quadriceps, their nerve cells don't hand off 5 batons to muscle cells. They literally hand it off to 5,000 muscle cells. So every time an action potential is sent from the nerve cell body located in the spinal column, it sends it down and simultaneously electrically tells thousands of muscle cells at the same time in the same muscle to contract. And that's the concept of a motor unit, is that you have a single nerve that essentially electrically stimulates or innervates a certain number of muscle cells. The larger the number of muscle cells that single nerve cell is attached to, the more force can be produced by a single action potential. Okay, so again, without getting too deep into the weeds, that's kind of the definition of the motor unit itself. Let me go ahead. Let me go ahead and clear all those guys and pull back out here and just kind of explain this to you now. So you got that picture in your head: single nerve, multiple muscle fibers. Every muscle in your body, right, has 3 different type of muscle fibers, right? We call them type 1. Now, technically that's not correct, but that's what we go with because that's the standard information that we have. So type 1, type 2A, and then type 2X. A couple of things to keep in mind to make it more real in your brain. Motor units those nerve cells only attach to the same type of muscle fiber. So you don't have a single nerve cell innervating a type 1 and a type 2X muscle fiber. No. Those individual, unique, discrete nerve cells always attach to the same exact type of muscle fiber, and then the numbers can change. And what we find is that for the most part, for motor units that are type 2X fiber motor units, you tend to see larger and larger groupings, bigger motor units, meaning more batons are being handed off by that single nerve cell to more and more muscle cells. Why? Because the generation of power requires not just the larger, powerful type 2X fibers in this case, but also lots of them. Okay. So where does the real world come in then in this? Well, think about it. If I can get more motor unit recruitment, that's what we call it. If I can get more motor units to work in the same period of time than I was able to do before, right? I do one exercise and I can get more motor units working like on a squat or a bench press. The more motor units that I can recruit at the same time, that's more muscle tissue that works at the same time. Guess what happens? I get stronger. I'm able to lift heavy weight, or I have more power, which is simply the ability to do work over a period of time. Okay. So, yes, I understand the concept of a motor unit, right? The single nerve cell, all the muscle cells it innervates may seem a little sort of esoteric in one sense, academic, but understanding that concept, it plays right into what we deal with when we're actually training people. So every time I'm working with somebody or I see somebody doing like a dumbbell curl and they're using 5, maybe 10 pounds and they're doing it incorrectly, or they're doing it too fast, or they're doing it too slow, the first thing that comes to mind is are they efficiently, effectively recruiting the most motor units that they can or should be recruiting for that particular movement? And just keep in mind, your motor units all over your body are functioning all the time. So even when I do a dumbbell curl and the muscle fibers in my biceps are working, right? The motor units are firing off and being recruited to do this amount of weight. Remember, I've got stabilizing muscles all over my body that are also getting fired off and holding the muscles, for instance, in isometric contraction. This is why you got to be careful that you don't do exercises incorrectly. The neurological system, the neuromuscular system is very unforgiving when you teach it something, when you teach it how to do movements in a particular way. For instance, I had a operation on my shoulder, right? Many years ago. And one of the reasons why was because I had, over time, whenever I would do curls, I would always lift up. So I was doing it incorrectly and it was a stabilizing muscle. What ended up happening is that the neuromuscular system, whose basic unit is the motor unit, right? Were being taught incorrect movement patterns, right? And over time, that created weaknesses and imbalances, and ultimately I injured it. So you get the point. Understanding something like academically the motor unit, you're probably not going to talk motor units to your clients, but keep in mind that understanding it is a critical element to resistance training. You've got to be thinking all the time, are my clients correctly recruiting, efficiently recruiting proper motor units, right? While they're training, are they doing the exercises properly? Are they doing them incorrectly? It all leads to whether or not the client is training properly. Are you going to potentially injure them? This all comes fundamentally down to an understanding of the motor unit. So I hope this was helpful. If you've got questions just on this topic itself, go ahead and leave them in the comment section below. Share this video if you think you know somebody that can actually benefit from this type of information. If you have any questions as well, even outside of this topic, we're more than happy to help you out with this. And again, I hope this was helpful. Subscribe to the page as well and hit that notification bell so that you know when the new material is coming in. And as always, have a great weekend and we will see you next week. Thanks.